Hello there, everyone. I wanted to take some time to go over predicting products, specifically products of single replacement reactions. In order to predict the products of single replacement reactions, we are going to use our activity series. And what we need to know about the activity series is that a more reactive element will replace a less reactive element in a compound. And the more reactive elements, I'm just going to first take this out the sheet protector. I'm going to show you an activity series here. The more reactive element are closer to the top, as you can see in this one. The most reactive element in this series would be lithium, and at the bottom you will see the least reactive element being gold. So if I'm dealing with anything in here, if it's closer to the top, it's more reactive. And if there's anything beneath it or below it, it will replace it in a chemical reaction. Okay. And so that's what we're going to do here. We have two examples that we're going to go through. So let's look at our first example. All right, we have HCl, which is hydrochloric acid, and we have zinc. And what we're going to see first off is if the zinc will replace the hydrogen in this reaction or in this compound here. And if that happens, then a reaction occurs. So I'm looking at zinc and I'm looking at hydrogen. I go to my activity series. Okay, I go to my activity series here. You can't really see it, so I'm going to stop putting it up here. Locate zinc on your activity series. Locate hydrogen as well. And you will see that zinc is more reactive than hydrogen, so that means it is going to replace it. And so zinc is now going to connect with the chloride ion. Zinc has a charge of 2+. Chloride is -1. So there would need to be 2 chloride ions for the one zinc ion. So the formula is going to be ZnCl2. Hydrogen, if you remember, is one of the 7 diatomic elements. So when hydrogen is by itself, it is H2. All right, and so the last thing we need to do is balance our equation. Okay, and if I put a 2 in front of the HCl, my equation's balanced because I have 2 hydrogens, 2 chlorines over here, 2 hydrogens, 2 chlorines over here. Okay, let's look at our next example. All right, sodium and magnesium chloride. So I do the same thing. I look at my sodium and I look at my magnesium. And if sodium's more reactive, meaning it's higher up on the activity series than magnesium, then it's going to replace it. It's like it's going to boot it out. Okay. So if I go here to my activity series, I see that sodium is indeed higher up than magnesium. So sodium is going to replace magnesium in this compound. Now, it is not NaCl2 because sodium has a charge of 1+. Chloride is -1. So they're going to come together in a 1-to-1 ratio, balancing out the charges. Magnesium is not one of the 7 diatomic elements. So when it's by itself, it's just going to be magnesium. Last thing I need to do is balance my equation. There's 2 chlorides here. There's only 1 here. I'm going to put a 2. That then makes 2 sodiums. And I put that 2 there. And the equation is balanced. All right. Well, the question is, what if the element is not more reactive? Okay. In this case, I have silver placed into a solution of calcium chloride. Going back to your reactivity series, you see that silver is not more reactive than calcium chloride. Okay, checking out your silver, checking out your calcium chloride. And since silver is not more reactive, you put the silver in a solution with calcium chloride, you will get no reaction. Okay, and so that concludes our video looking at predicting products of single replacement reactions. If you have any questions, please, you can contact me by dropping a comment on the video if you're able to do so. Or those of you that are my students, you can always get me by email or personally in class. Thank you for watching.